Hello student, in the last lecture we have seen that definition of the derivative, then finding the derivative by using the first principle, then derivative of a constant function and derivative of power function. Now we will take the derivative of some trigonometric functions. And there are 6 trigonometric functions. So first function is sine, then cos, then tan x, and sec x, cosec x, and cot x. So there are these 6 trigonometric functions. So first of all, we will take the first derivative of a first trigonometric function, sine x. Trigonometric functions. Trigonometric functions. So first, sin x. Derivative of sin x is equal to cos x. So let function f of x equal to sin x. So then we put where there is x is x plus h. So it is the sine of x plus h. Now by first principle method. First principle method. So derivative of f dash x equal to limit as it tends to 0 f of x plus h minus f of x upon h, limit as it tends to 0. We put here the value of this function f of x plus h and function f of x. As it tends to 0, the value of function f of x plus h is sine of x plus h, and value of f of x is sine x minus sine x divided by h here. Now we use here the expansion of this sine of x plus h minus sine x by using factorization formula. So here limit as h tends to 0, so sine a minus sine b, using here sine a minus sine b, it gives 2 cos of a plus b by 2 into sine of a minus b by 2. We use this. So therefore a means here x plus h and b means x here. So it gives 2 cos of x plus h means a, and this b, x is b here, plus b means x by 2 into sine of a minus b. A means x plus h minus b means x here by 2, and whole divided by h here. And so therefore limit as h tends to 0, it gives 2 cos of, here x plus x, it is 2x plus h by 2 into sine of x plus x minus x will cancel, it is only h by 2 whole divided by h. Now so when we divide separately by this term by x, so 2 will get cancelled and it is h by 2. So therefore it is limit as h tends to 0, 2 cos of x plus h by 2 into sine of h by 2. Here multiplication sign. That's why we divide this sin h by 2 to this h, and this here this h, and here the angle of sine is h by 2. That's why we adjust here 1 by 2. So we have to divide and multiply by 1 by 2, and so therefore these two and these two will get cancelled. So therefore we apply limit separately. Limit as h tends to 0 cos of x plus h by 2 into limit as h tends to 0 sin of h by 2 upon h by 2. And so apply limit as h tends to 0, where there is h we put 0, 0 upon 2 it is 0, so it is cos x only, into here it gives 1, because here limit of a sin theta upon theta as theta tends to 0, it gives 1 by using this formula. So it is 1, and therefore it is only cos x, so that is f dash x. It is f dash x, f dash x. But here fx means, so f dash x means it is the derivative of function f of x. Derivative of f of x is f dash x, so derivative of sin x is cos x. And so we write in this way also. Therefore derivative of sin x function is equal to cos x. Hence we have to find the derivative of sin x is cos x. Now we will take next trigonometric function, derivative of trigonometric function tan x here. Now the next trigonometric function tan x, derivative of tan x is sec square x. So let function f of x is equal to tan x, then we put, where there is x we put here x plus h, so it is tan of x plus h. Now by the first principal method, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0, we put the value of this function f of x plus h is tan of x plus h minus f of x is tan x divided by h. Now we write this tan is a ratio of sine and cos. That's why we write sine of x plus h upon cos of x plus h minus sin x upon cos x whole divided by h. Now in the numerator here, take cross multiplication and LCM here. So it is sine of x plus h into cos x minus, right, cos of x plus h into sin x whole divided by here cos of x plus h into cos x, LCM and cross multiplication and LCM here whole divided by h here. Now we use here addition formulae. So addition formulae. So sine of a minus b, it use sine a into cos b minus cos a into sin b. We use this formula. A means here it is x plus h and b means here x. So here sin a into cos b minus cos a into sin b. So we have the right hand side, so we write left hand side. this formula. So it is equal to, it is f dash x. So limit as h tends to 0. So actually it is the expansion of sine of x plus h minus x. Sine of x plus h minus x. Sine of a minus b. Then divided by cos of x plus h into cos x and whole divided by h here. How do we write this h here? Yes. And so therefore here plus x and minus x will get cancelled. So it is only sin h. It is equal to limit as h tends to 0 sin h, take this h, sin h upon h into, we write this denominator as like this, cos of x plus h into cos x. Okay, now we apply limit separately here. It is equal to limit as h tends to 0 sin h upon h into 1 upon limit as h tends to 0 cos of x plus h into cos x. Okay, and so therefore this is nothing but 1, because limit of sin theta upon theta as theta tends to 0, it is 1 upon then here apply limit as h tends to 0, means it is 0, so x plus 0 it is x only, so cos x into cos x, it is cos square x, it is cos square x. So therefore 1 into 1 by, but 1 by cos square x is sec square x, 1 by cos is sec x, so it is a sec square x. So f dash x equal to sec square x. Hence derivative of tan x is sec square x. Therefore we write derivative of tan x. Here it is function fx, because function fx is tan x. So derivative of tan x is equal to sec square x. Hence we have to prove or find the derivative. We have find the derivative of tan x is sec square x. Now we will take another trigonometric function that is a sec x, derivative of sec x. So the derivative of sec x with respect to x is equal to sec x into tan x. So let the function, our function f of x is sec x, and we put here where there is x, it is x plus h, sec of x plus h here. Now by first principle, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0. So put here the value of function f of x plus h. F of x plus h is here sec of x plus h, sec of x plus h minus f function is f of x is sec x, whole divided by h. Here we know that sec is a reciprocal of cos. That's why we write this sec of x plus h in this way, 1 upon cos of x plus h minus 1 upon cos x whole divided by h. Now again we take cross multiplication here and LCM. It is equal to limit as h tends to 0, so it is cos x minus cos of x plus h divided by cos of x plus h into cos x into the h, take this h, or here also, whole divided by h. Now again we use here of factorization formula, cos a minus cos b, or sorry, it is a, yes, cos a minus cos b. So here f dash x equal to cos A minus cos B. It gives 2 sine, addition formula. Cos A minus cos B, it gives minus 2 sine of A plus B by 2 into sine of A minus B by 2. So therefore it is a minus 2 sine of A plus B. A is here x, x plus h, B is x plus h by 2 into sine of A minus, due to this minus sign, this plus also minus, A minus B here by 2 whole divided by h. Yes, divided by this cos of x plus h into cos x, and we write this h here into h. Now here this x plus x, it is 2x, 2x by 2, it is x only, plus h by 2, and this plus x minus x will cancel. So limit as h tends to 0 minus 2 sine of x plus h by 2 into sine of minus h by 2, or take this h here into cos of x plus, so we take this term into 1 upon cos of x plus h into cos x inside here. Now we take a limit, we will take limit separately. Limit of, take this minus 2 here, minus 2 into limit of sine of x plus h by 2, limit as h tends to 0, into limit of minus h by 2 upon, take this minus sign here, so add this 1 by 2 here, h by 2, 1 by 2 into 1 by 2 here, into 1 upon limit of cos of x plus h into cos x as h tends to 0. Now we apply limit to each and every term. So therefore here this minus minus become plus, and 2 will get cancelled. So therefore limit of sine of x plus h by 2, when we apply limit as h tends to 0, it is a 0 by 2, it is 0, it is only sine x into, and the value of this limit is 1 into 1, then into 1 upon, when we apply limit as h tends to 0, this 0, it is h is 0, so it is only cos x into cos x, cos x into cos x, it is a cos square x. And so therefore take first sin x upon cos x into 1 upon cos x, and we know that sin by cos is tan into 1 by cos is sec x, and therefore it is a sec x into tan x. It is, this is nothing but f dash x. So f dash x is the delta of fx. Delta of fx is f dash x. So delta of sec x is sec x into tan x. We may also write in this way. So f dash x, it is a derivative function sec x with respect to x is equal to sec x into tan x. Hence, we find the derivative of sec x is sec x into tan x. Now the remaining derivative of trigonometric functions like cos x, the derivative of cos x is minus sin x, derivative of cosec x is minus cosec x into cot x, and derivative of cot x is minus cos x. You may try to solve it home. Now we will take the next function, that is exponential, derivative of exponential function. There are two exponential function. First is a raised to x and the second is e raised to x, and the derivative of e raised to x is e raised to x, and the derivative of a raised to x here. Derivative of a raised to x is a raised to x into log a, where x is positive. Let consider the function f of x equal to a raised to x. We have to consider this function. So then we put a f of x plus h. Where is this x? So we put x plus h. So a raised to x plus h. Now by first principle, so f dash x, derivative of fx is f dash x is equal to limit as h tends to 0 f of x plus h minus f of x upon h, limit as h tends to 0. We put the value of function f of x plus h and function fx. F of x plus h is nothing but a raised to x plus h minus fx is a raised to x divided by h, and therefore limit as h tends to 0. We take common a raised to x here. When we take common a raised to x from this a raised to x plus h, it remains only a raised to h, because whenever in multiplication denominator are same, then add the power. And here we take common this a raised to x, it is only 1 here, divided by h, divided by h only. And so therefore a raised to x is a constant, take before the limit. So a raised to x into limit as h tends to 0, here a raised to h minus 1 upon h, and the value of this limit, it is the log a. So therefore it is equal to a raised to x into log a, since limit of a raised to x minus 1 upon x, the limit as x tends to 0, you use log a formula for the limit. By using this formula here, there is change in only x. Here it is x tends to 0, x, here it is h here, that's why. So therefore hence derivative of this function a raised to this exponential function a raised to x is a raised to x into log a here. Hence we prove that the exponential function, the derivative of exponential function a raised to x is a raised to x into log a, and the another exponential function is e raised to x. So you may try to solve at home. Derivative of e raised to x is e raised to x. Now we take the next function, standard function, logarithm function, derivative of a logarithmic function. So then the next function is a logarithm function, derivative of logarithm function. So derivative of log x is 1 by x, x is positive here. So let the function f of x, fx is log x. We put here then f of x plus h, where there is x, x plus h, log of x plus h. By first principle, f dash x equal to limit of f of x plus h minus f of x upon h as h tends to 0. We put the value of function f of x plus h and f of x. So the value of f of x plus h is log of x plus h, and the value of log x fx is log x whole divided by h. So we know the rule of logarithmic. Here it is log a minus log b, it gives log of a by b. So this is the rule for logarithmic. It is log of a by b. A means this x plus h upon b means x upon h here. Now divide this term by x. It gives as h tends to 0 log of so it is 1 x by x is 1 plus h by x upon h. So here we adjust h by x adjusts. So it gives h tends to 0 log of 1 plus h by x upon h by x. We adjust here 1 by x into 1 by x. We divide and multiply. Take log on both. Take limit to each and every terms separately. Limit as h tends to 0 log of 1 plus h by x upon h by x into limit of 1 by x as x tends to 0. So here, since limit of log of 1 plus x upon x, it gives 1 into limit of 1 by x as h tends to 0 here. The h is absent here, that's why it is 1 by x. Since limit of log of 1 plus x upon x as x tends to 0, it gives 1. So we use here this formula. So therefore it is 1 by x, and so it is f dash x. So the derivative of fx means log x is f 1 by x f dash x. So in this way, also write in this way, derivative of log x is equal to 1 by x. Hence we have find the derivative of log x is 1 by x. It is the logarithmic function. Now we will take next article, relationship between differentiability and continuity. So the relation between differentiable and continuous function. So there is a theorem. So the statement of the theorem, prove that every differentiable function is continuous. Every differentiable function is continuous. So proof. Let f be a function, f be a differentiable function. At x equal to a. So we know that if the function is differentiable at x equal to a, then its limit, it exists, limit of f of a plus h minus f of a upon h as h tends to 0. This limit is exists because the function is differentiable at x equal to a. Limit exists, and therefore we write this we write this limit as f dash a. F dash a is equal to this limit. Yes, we given the function is differentiable at x equal to a, and now we prove that this differential function is continuous. So we need to prove that function f is continuous at x equal to a. Function f is continuous at x equal to a. So that is, we prove or we show that, we prove or show that, we show that when we say that function is continuous at x equal to a, if limit of that function is equal to function of that point, limit as x tends to a f of x, limit of that function f of x as x tends to a is equal to function of that point. Point is x equal to a. So that is limit of function f of x minus function f of a as h tends to a, or x tends to a, x tends to a is equal to 0. So we have to show that. That is, we show that here. This now, so put x equal to a plus h. This x equal to a plus h, and then as x tends to a, h tends to 0. When we put any function, then interval changes. As x tends to a, interval changes, h tends to 0. So therefore our function is here limit of as h tends to 0 f of a plus h minus f of a is equal to 0. So we prove this. Now take, so we have to show that. So we need to prove this. This call equation 1 here. So now we take the left hand side limit, left hand side here, and prove our just here. Now we take limit of f of a plus h minus f of a as h tends to 0 is equal to limit as h tends to 0 f of a plus h minus f of a. As h is not equal to 0, h tends to 0, h is not equal to 0. We add this h here. As h tends to 0, h is non-zero. We add this here. We add and multiply. We divide and multiply by h. Now we apply limit separately. Limit of h as h tends to 0. So when we apply, so by 1 here, by equation 1, this is f dash a into, when we apply limit as h tends to 0, it becomes 0 by 1, and so therefore it is 0. So hence we have to show that this function is equal to therefore hence the function f is continuous. F is continuous at x equal to a. Hence we have to show that given differential function f is continuous at x equal to a. The converse part need not be proved here. The converse part here, the continuous function is need not be a differentiable function. Hence we prove the theorem. So today we will stop here.